Hello and welcome to the Crystal Podcast on iCode Media. Today I'm going to have a conversation with Dr. John Nolan. We're going to talk about how to evaluate evidence, and we're also going to talk about why null hypothesis and correct hypothesis are important when projecting forward into a study. So it's been a couple years since I talked to Dr. Nolan. I know it's going to be a really fascinating conversation for me. I hope it is for you. As always, please be sure to subscribe to the podcast, write a review, share it with your friends, and support those who support us. I want to talk about the MyDay multifocal for a second. We had the opportunity to do a preclinical trial with this lens this last summer, and there were a couple things that I thought were really helpful. The first one is that it is different than a lot of the multifocals that we've used before in our practices, where patients, especially early emerging presbyopes, really managed it didn't cause a lot of additional distance blur for them. And the other thing that was really helpful was, because we've never been involved in a clinical trial before, was to understand the sort of questions that we might ask our patients. And we ask our patients a lot of questions about their satisfaction with a contact lens, but what we weren't doing was actually having them score that themselves. So one of the parts of this that was really interesting to me was asking patients on a scale of 1 to 10 how they would score their vision, how they would score their comfort in their current lenses, and then how they would do the same on their new lenses. And it showed me a lot of times where patients would say they were happy, might rate their vision as a 6 or a 7. And then it also reframed their thinking about their current satisfaction in their lenses and allowed me to open up the door to offering other solutions. So if you haven't tried something like that in your clinical practice, I would encourage you to. And I would also encourage you to try the MyDay multifocal for your patients. So Dr. Nolan, thanks so much for doing this. You look way more dapper than I do today. I should have put on my at least a jacket. But this is fun. You probably had a full day in Ireland, and I'm just kind of getting started. So what's been going on over the last couple of years?
Yeah, I've had a full day in the sunny southeast. As you can see from I'm in my office now, and you can see maybe out the window the beautiful green of Ireland. So that's our lovely greenway, which I have the pleasure of looking at every day. So yeah, we're on that Friday feeling, I suppose. It's been a good week with everyone. Lots going on as always at the NRCI. The researchers are doing so well, really strategizing now for the next phase of projects that we're running. But also, I suppose there's been a lot of work in preparation for our Bond conference, which happens this summer in Cambridge, UK. So this is our network of carotenoid scientists where we all get together and in a very positive way challenge each other on the science and network, and this is really the platform where we see the next big idea or the next group of scientists that can bring so much to what is a multidisciplinary piece of research. So yeah, it's good. It's good. I remember the last time we spoke, we were right at COVID had just started, and we were both trying to tread water and figure out where we were going to go. So slowly, surely and carefully, I think we've managed to get back to this kind of physical place where we can meet each other and conduct research again the way we want.
It's really surreal when I go back and I don't listen to many of my podcasts historically, but I go back and listen to some of the podcasts that I did in basically a year ago, and you could feel the stress in my voice. I can hear it, and I can feel how like the weight of the world felt like it was on my shoulders. As a business owner, you know this, as a business owner or practice owner, you're trying to make sure that you have a place for your people, and so it's just a really weird spot. And I listened to that, and I'm like, oh, I can tell how stressed out I was. Do you ever have that sense? Have you ever gone back and listened to something that you were doing right in the middle of the pandemic and feel your stress level? Maybe you're 100%. A better person than I am.
No, 100%. Because I, like you, have a young family, and it wasn't just that we were trying to, understand how we were going to continue with our careers or how we were, as you rightly say, support our colleagues. It was like we had our family to mind, and we had to do homeschool, and we had to, just find different ways. But, I think, firstly, congratulations on your own podcast, because I think these types of discussions, and even back then, when we look back now, they were so useful, weren't they? Because, maybe there was too many of them or whatever at times, but ultimately it did form a different type of way to communicate and a network. And I got a lot of comfort from that from a research perspective, and the whole idea of keeping the connection with doctors, with the ODs, in terms of that discussion, that communication, that education. Platform like yours have been fantastic. So I experienced all those feelings you had, but I think we learned so much, didn't we, as well, during that time?
Yeah, I hope we did. I certainly hope we did. I mean, I think we learned about our resiliency. I think we learned about how to navigate uncertainty. And actually that kind of will springboard us right into our conversation, because one of the things that, so I'm not trying to divert, because you and I could talk a ton about that. And I hope to someday be able to do it in person over a beer next time you're on this side of the world. But actually navigating uncertainty is one of these things that a lot of people feel like, outsiders, outside of healthcare settings. Without going into too much depth, I just had a conversation the other day with a group of people who are independent, who are analyzing a change in scope of practice for the profession of optometry. And you mentioned this rigorous debate that goes in with the carotenoid evidence and the scientists that get together and go back and forth. And what most people don't see is that in healthcare, in science, and I think we got away from this, at least in the United States, our media did not do a good job during COVID, highlighting the nuances of rigorous debate that goes on in scientific communities and in healthcare communities. And so to try to, discuss that debate and how you can know different things are important, and how you can know that, some evidence is valid and some evidence isn't. Those are nuances that my suspicion that the general public and even, doesn't appreciate fully. And so, for example, when we think about glaucoma, you can get, 100 experts. I mean, top of the, world-class experts in glaucoma, and you can get them all in a room, and getting them to agree on one case about whether they should treat or, increase treatment or do this surgery or that surgery. You're not going to have that happen. And so I think there's this idea in the public that in healthcare, it's like, oh, well, if John Nolan does this, and then everybody's going to do that. If this study tells us this, then everybody needs to do that. And so I guess my whole diatribe there is to say that, these discussions are way more nuanced. They're way more fun to have. But in order to springboard into those conversations, we've got to understand the hierarchy of evidence. And I wanted to just start kind of by talking about how you view that and why that's important to you as a scientist.
Yeah, I think it's a perfect preamble into what we want to discuss today. And, I think the whole element here of and the whole point of this is the evidence base, and if you think of it let's just think of it from an optometrist perspective, he or she has so much going on, busy practice, all the stresses of running a practice or being part of a practice and delivering a good service for the patient. When something new like macular nutrition comes to play, and this whole something that they weren't trained in, if we were to think about it, classically nutrition is a relatively small part of optometry training, and ophthalmology training, and then we're saying as scientists, oh, you should do this because we have evidence to suggest you should do so. And even the best study, and we'll talk today about the levels of evidence, but even the best study might have so many limitations that need to be addressed maybe for the next study. That's why there's always a next study. There's always a new way we can do things. But to answer your question, I think, if, optometry and eye care is to embrace in nutrition, for example, and want to know how to make the right decisions in order how to do that, I think living in a currency of peer-reviewed scientific evidence is the safest way to do that. But there's a couple of key assumptions, right, within that, and it's good because I'm going to kind of address some of these today. Even if it's peer-reviewed publication, which what I've been saying from the podium to the hundreds and hundreds of ODs that I've spoke to across America and so on, that peer-reviewed is the way to go. But even within that, there can be challenges if the peer review isn't appropriate, or if the methodology isn't state of the art, and if the study design isn't optimal. So I think there needs to be an understanding of the different levels of evidence and the different types of evidence. And if we, what I might do actually, it's probably a good time to share my screen.
Yeah, just go ahead and share it. Let's see what you got.
Yeah. So what we see here now is the pyramid in terms of levels of evidence. So the first thing to say here is, in terms of levels of evidence, what doesn't even get in here is something like a magazine article that has, maybe a story, or some company may, get someone to write an article and it gets put into a magazine article, an optometry article. That's not peer reviewed. Now, I'm not saying that what's in that content is not valid. It may have some information that's very useful. But I suppose the first point to say is that be very cautious in terms of the information that you're getting that exists within the non-peer reviewed world. Okay. So essentially what the peer...
So yeah. Professor Nolan, just so I can summarize what you're saying for people who are just listening, is everybody remembers this this pyramid of evidence. And just, the base of that, kind of the lowest portion of that, is animal laboratory studies. Then we have case reports or case series, case control studies, cohort studies, randomized clinical trials, and then, obviously meta-analysis, and then clinical practice guidelines on top of that. Exactly. So I wanted to point that out for those people that are listening. And I think to your point about, kind of, it's derogatory, I suppose, but I call them throwaway journals. They're not, it's not that they're not valuable. I think they are valuable, but nobody kind of collects those journals and archives them generally. They read them once and then they toss them in the can. So that's what you're referring to is those types that aren't peer reviewed.
That's right. And it's those articles, and as you've just said, maybe there's some value in them, but in terms of certainty, in terms of taking levels of evidence and certainty around evidence, that if it says that a particular nutritional supplement is good, well, of course the magazine is going to say that, because surely some organization that's selling that supplement is sponsoring that, and so on. So in theory, at least, the place that we can draw our information from, where we can make decisions in the clinic setting, would be to look at the peer-reviewed science. And that's typically a platform which is a scientific journal, ideally a journal that has a high impact factor, which means that it has a high readership, and that the reviewers within that system are expert enough to look at a new piece of research. So research has to always be related to some type of hypothesis. And a hypothesis, quite simply, is, it's an idea of something that we don't know because it hasn't been tested properly or it hasn't been shown before. Okay. So that's how we progress science and thereafter inform medicine, clinical practice. You see, if you look at it on the slides here, you can see at the top of that. Ultimately, that's the ultimate dream of a scientist, that you can contribute to peer-reviewed science that finds its way into the clinical situation, because that means that we're affecting society in a positive way, particularly in our area of research where we're looking at human health, nutrition, macular pigments, and so on. So looking at all of these, and all of these types of peer-reviewed studies will have value. And as you've labeled them, I'll just quickly go through them again. The case reports are something that would be classic in when I look at speakers, maybe from optometry practice, that come to, say, COPE events and so on. They may be presenting case experiences, and they may be and typically they're pretty excited about individual cases. And this happens in medicine as well. We see it the whole time. And sometimes cases are very useful, but they're also very limited, because they're exactly just that. They're just cases. They're just examples of what might happen with a very small, sometimes even only one sample, one case. So while that may be informative or suggestive that there's something important here, it really needs to be extended to a broader research question and a more refined research question. And
so to put a little finer point on that, Professor Nolan, where you get the case control studies, generally speaking, is I see an observation in my practice that I think is unique. And I see that 3 or 4 times, and I might say, look, I'm going to report on this to a broad swath of people, and I'm going to have a hypothesis on why that happened for those specific patients. And then somebody else is going to say, look, I take that Chris Wolf's idea, and I'm going to say, let's do a series, a study on a case control. And that brings us to this next level of evidence, essentially.
Exactly right. And that's where you might say, well, let's just stay in our field. So, for example, patients with macular degeneration have a lack of macular pigment. That might be the hypothesis. And you may believe that in the first instance, in the first case, because you may have measured it in an AMD patient and they have low. But you don't really know until you compare it to a control. And the control here, by the true definition, would be a patient of the very same type of genetics, age, profile, that doesn't have the disease, but yet has this lack or this deficiency of macular pigment. And if you show this piece of research in that case control, now we have a little bit more evidence to believe that it may actually be the case. Okay, does that make sense?
Yep.
Perfect. And progressing through that, then, and moving on to the kind of more serious levels of evidence, what we have then are cohort studies, which essentially are these kind of large sample studies which have a longitudinal nature. So you may have a research hypothesis here that having macular pigment is a risk factor for macular degeneration, and those who do not have enough of the pigment will develop the disease in the future. So how would you test that? Well, it's very difficult, and it's why it's a high level of evidence, because you have to have a lot of people with those measurements performed, and you typically will have to follow them over a period of time, typically longitudinal investigation. So ultimately follow them throughout the years, throughout the decades, to see if that hypothesis was correct. So very, very expensive type experiment to do, very difficult experiment to do. But if you can do these large longitudinal experiments, they can be very, very valuable indeed. And then I suppose the area that the listeners and the viewers may be more comfortable or familiar with would be when we talk about these randomized clinical placebo-controlled trials. And these are really what we kind of specialize at the Nutrition Research Centre Ireland, where we have, in our case, various interventions that we believe are going to be effective. They're going to help increase the macular pigments, and they're going to improve vision and so on. And that's our hypothesis, our test hypothesis. But in order to test that, again, a very difficult experiment, when it's done correctly with state-of-the-art methodologies, very expensive to run. And it doesn't take just one individual or one skill set, say optometry. In this situation, you're looking at multidisciplinary, you're looking at statistics, you're looking at experimental science, you're looking at vision science, you're looking at running clinical trials, you're looking at all of these brought together. And we're going to today speak about CREST and the work that went into the CREST experiment in part, and took 6-7 years even post getting the funding to do it, to deliver the experiment, to interpret the experiment, and to publish the experiment. And that's why we put so much value on the likes of the CREST trial, which was conducted in the way it was. And then I suppose the pinnacle of all this, as I said, is to get it to use in clinical practice. But this other type of peer-reviewed paper, where what we call a meta-analysis or a systematic review, which is where independent qualified experts will look at these research questions and will look at the totality of the evidence. So taking everything from the case studies up to the level 1 evidence, which is your randomized placebo-controlled trials, and basically making an assessment, and there's strict rules on how you would do that, as to whether the hypothesis is actually a true hypothesis and something that brings value and thereafter gets to be used in the clinical practice. So when we
let me pause you there really quickly, because I think this next piece is important. But you talked about funding. When you get to the portion of a randomized control trial, and it's quite expensive, where do most researchers get the dollars for that type of funding?
Okay, so we typically will do what we call a competitive grant assessment. So what we'll do is we'll look at what funding agencies. In our case, we've got significant funding from the European government, so essentially from the taxpayer. So there's certain monies, and in America, you look at the NIH, National Eye Institute, which is similar. That's essentially government taxpayers' money that goes in, and essentially these organizations will set up appropriate research calls. So ideally a call is you want to fix a particular problem. So when I wrote my CREST protocol for funding through the European Research Council, there was about 2 years preparation in just writing the experiment, because you will only get the funding at the level we did, almost 2 million euros, if you have a study design that is very well developed, well informed, state of the art, suitable to address the question. So to answer your question, we get it from independent competitive grants such as the European Research Council for the CREST study.
And so I think that's important to think about, is that, a lot of your research has been used by specific companies, right? And we don't have to disguise that. But I think the underlying funding, which I wasn't aware of, is coming from sort of this independent governmental agency that helps drive the evidence, which I think is pretty important. I think it's an important point to point out.
Yeah,
why not? So let me ask you this then, like what's the next threshold step between going through a randomized controlled trial and then saying, look, I want to prove this through I guess it would be a European type of FDA. What would be your step in going through that type of process? What would that look like? Or is it not an issue with supplements?
Well, I think it can be enhanced, and I think multi-centered efforts. We're already seeing it, that other people kind of take the ideas from the research question. In our case, it was the use of the triple carotenoids, the 3 carotenoids, and that's replicated elsewhere. Ultimately, the goal now is that this science is used where we go and we speak to government to make it appropriate that, these types of safe nutrients, which are validated now, which have efficacy, which have demonstrated benefits for patients with macular degeneration, for example, that there's a bigger effort kind of from government to make it feasible for patients and doctors to get access to those. But I want to go back to one other point that you made, because I agree with you. It's truly important. The whole concept. Well, Nolan is saying, the 3 carotenoids because he's done all his work with macula health, for example. Absolutely right. That's the case. But it's good that you've shown the light on the reason for that. And the reason for that is, just like everything we do in our scientific experiments, is we want to have the best way to measure macular pigment. We want to have the best way to measure visual function. Part of the statistical methodology and study methodology rather here is having the best supplement. We didn't just pick the macula health supplement. We spent nearly 15 years testing all types of supplements. It was when we got access to the macula health supplement that we started to see in single blind experiments much better results. So therefore, it only made sense that was the supplement that we selected to use in our major European trials. Okay,
and that brings us to the idea of a hypothesis. You can have a hypothesis that is one way, and if you're using a supplement that you believe doesn't, based on the evidence that you've evaluated, isn't going to perform a way, then you could do a whole entire expensive CREST study, and then you have to wonder, did it work? Did it not work because it was a bad product, or did it work? So I think that's kind of the next point, and I'll let you kind of talk about your perspective of a null hypothesis.
Yeah, no, thank you, and you're right. Because like we've published papers pre our most trials, which were mesozeaxanthin trials, where we had been using lutein, and in some of the cases, the lutein wasn't even getting out of the tablets because it was so encapsulated in the hard tablets. Patients were getting very little response. And how did we know that? When we look now retrospectively, even at our blood data, there was very little benefit from taking those interventions. So essentially we were comparing placebo to placebo. And then the other problem was when we started to use lutein, albeit in a kind of more bioavailable pure form, we still saw this non-responder, this large percentage of the population that were not getting any benefit in terms of their macular pigment from this type of intervention. And it was all of this evolution of the idea that led us through the use of the 3 carotenoids, which took us to our research question, which was the null hypothesis is basically, in the context of macular pigment, was basically the hypothesis that I was trying to disprove. So the null hypothesis in the context of the macular pigments and the macular carotenoids says that taking the carotenoid supplements has no benefit in macular pigment or vision. So as the researcher, we were trying to disprove the null hypothesis. So in order to do that, we had to conduct an experiment that had the appropriate supplement. As you know, we use macula health that had the appropriate measures of vision. We measured contrast sensitivity, and we've spoken before as to why contrast sensitivity is such a sensitive measure. But also, in terms of measuring macular pigment, that we were able to image the totality of the pigment, that the variability of the measurement was low. So it was the nuts and bolts of all the elements of the experiment that had to be put in place before we could even logically address a research question like, does taking an appropriate supplement enhance visual function in patients with macular degeneration? And our research question in CREST had two elements. One was for macular degeneration. Could we enhance vision when we use the 3 carotenoids versus the supplement that didn't have the 3 carotenoids? But for the general population, it was simpler. It was if the people on the active intervention took this carotenoid supplement that had lutein, zeaxanthin, and meso, could we significantly increase the macular pigment? Could we enhance their visual function? The null hypothesis said we couldn't. So we had to conduct the experiment to disprove that. And if we were to disprove that, well, then we had delivered level 1 evidence, just like at the top of our pyramid, that should inform the clinical setting, that should give the doctor, going back to the very first point that we discussed today, the confidence to know that this is the right thing to do based on best scientific methodology.
Yeah, so that's great. And just to articulate, you keep saying tree carotenoids. And so I love the way you say that. So obviously it's the first time you said it, I was like, tree carotenoids? No, 3 carotenoids. Okay. Yeah. All right. So no, we're good.
And here you can see them, lutein, zeaxanthin, and mesozeaxanthin. And as I said already, our test hypothesis here was that enriching this pigment with the purified safe supplementation would enhance visual function. And we won't go into it today, the reasons for that, but the idea being that you're going to make the macula healthy because it has antioxidant properties. You're also going to optimize the use of light at the macula. You're going to reduce the impact of short wavelength blue light. You're going to reduce photooxidative stress. And ultimately, we knew going into this experiment that general society had very low levels to begin with. So quite remarkably, then we conducted the experiment. I'm showing you the general experiment from the healthy population. So today we won't speak about age-related macular degeneration, but in a basic research question here, I put this up. This is actually really, really important in the context of the validity of design, and we talk about the quality of the type of intervention. So what I want to say here is, it's not just, Chris, down to the fact that you're doing a double-blind placebo-controlled trial. It's the quality in which you implement that is equally important. We spoke about having the right supplement. We spoke about having the right testing systems to measure pigment, to measure vision. And the efforts we went to with CREST were that we actually published a paper before the experiment, which presented our hypothesis, which presented all our protocol in terms of everything we were going to do, and also our outcome measure. And what that means, if you do a trial of this level, it means you can't change your outcome measure based on what the data shows you. You can't go looking at contrast and just because you don't see anything, maybe say, well, glare is reduced or, acuities are improved. If we had failed by improving contrast, the conclusion from our experiment would have been that the null hypothesis was correct. We couldn't disprove it. So it was a really big task, and it was a really informed task. Do you understand kind of what I'm saying in terms of like this quality piece in terms of protocol?
So essentially what you're saying is that you're preempting. You're saying this is what we believe is going to be important to disprove the null hypothesis. And if it's the case, so you're going to put that out there for everybody to see. And if it's the case that doesn't occur, you can't hide it. Exactly. I can't go out and say there's 30 different things I'm going to measure. Yeah. I'm not going to tell you what those 30 things are, but then I'm going to publish the things that wind up being positive on my side. That's what you're saying.
Exactly right. And you can see this was published in 2014, so long before we even had access to the data for analysis from these interventional trials. And as we move on, let's see. The first thing I want to show you here is the study design. So it was a placebo-controlled trial. So that means that 50% of the participants who were healthy in this case had a placebo. They had no active ingredients, and 50% had the MacuHealth 10-10-2 formula. All participants had low pigment to begin with, and as pre-published, contrast sensitivity 6 cycles per degree was our primary outcome measure. And I want to show you this in terms of one of the outcomes. We see This shows you time over 12 months at the x-axis and the bottom axis. So for those of you who can't see, we're showing a graph of the response. And clearly what you can see here is that the placebo group had a really flat line, which is perfect. That's what you want to see with a placebo group. And the active intervention, this is mesozeaxanthin, this is lutein, 600% improvement, for example, and this is zeaxanthin. And you can see here, therefore, this gives us also a couple of things. It gives us confidence in our methodology, that our HPLC, which is basically the analytical methods that we use to quantify the carotenoids that are going into the blood system following consumption of the intervention, that we can see that it's going on its way. I like to call the blood system the taxi system. It's what delivers these carotenoids to the target tissue, in our case, the macula and the brain. And also, this is important in the context of a proper trial, because you understand that your compliance and that the bioavailability of the intervention is where it should be. So really, really, and, let's pause for a second, because this is one slide, but this probably took, someone 4 years to do this type of analysis, who just specializes in analytical chemistry, who knows how to run those systems. And we're very lucky at the NRCI. We have all this capacity across our multidisciplinary team. So Alfonso, being the head of the chemistry lab, will manage all the protocols, where the scientists will take the blood samples and quantify it this way. So really, this is the type of data you should be looking for when you look at a paper that's making strong claims around a type of carotenoid intervention, for example.
Professor Nolan, if somebody were going to argue against the point that you're making here in terms of blood serum or serum concentrations of carotenoids, where they might say, we don't believe that mesozeaxanthin is that important, how would they dispute that based on this data?
Well, it's quite difficult too, because what you learn from it is that you learn that the human that consumed on average, and it was across all of them, you can see the narrow standard errors, they all got a significant change in their mesozeaxanthin. One of the things that may and has wrongly been disputed over time was that by taking mesozeaxanthin, you're reducing the other carotenoids, right?
Right. And tell me about why that's not the case.
Well, in this trial, I can tell you it's not the case, because I know it's comparable to and it represents actually the best response that we've seen in blood, having measured lutein, zeaxanthin, mesozeaxanthin response in blood. So it would be the case that if I had very small changes in lutein and not typical of what I had seen previous. I can answer it better by looking at the CREST AMD data, where we actually had a lutein group versus a mesozeaxanthin plus lutein group. And in summary, the lutein response was identical. So it clearly doesn't have that competitive effect. And it makes sense to me that it wouldn't at the levels that we had worked with. And the other point, Chris, is that this was all following informed previous work. So we didn't just go to 10-10-2. We had spent years. I'd worked up as high as 17 milligrams of mesozeaxanthin in one experiment. And ultimately, it was informed science that showed us that having 10 milligrams is giving you the optimal amount. But I'm glad you asked the question, because it has been a misconception within our field. And here you can see that these humans on the active in CREST did fantastic in terms of their response, right?
And so to amplify that a little bit more, because I'd like to get your opinion on this as well, is, it's not even just about the serum levels, but what actually is contributing to the macula as well. And so what you're saying is that the 10-10-2 is superior and doesn't lead to competition of just straight lutein and zeaxanthin, and prohibit a macula from causing conversion of zeaxanthin or of lutein into mesozeaxanthin. So that's the other kind of side of this, is that you can get the serum levels up, but that doesn't really matter, because your macula is going to convert everything anyway. So you're just competing with other forms. So what are your thoughts about that? I mean, I know you alluded to it, but how do we know that isn't the case?
So we know it's not the case in the blood. Let's look at the macular pigment itself. So here you can see actually the tissue, and here you can see the placebo group then showing your exactly what you want, again validating our measurement. Well, can you see the macular pigment response here, Chris? This is the macular pigment volume, and this is the central part. You can look at either the peaks or the entire volume. And a couple of things. 100% of the participants that took the MacuHealth 10-10-2 intervention had a significant response in their macular pigment. So everyone got benefit.
So it gets from their gut into their bloodstream, into their macular pigment.
Yeah, so essentially it goes from the gut, it has to be microencapsulated, it goes through the intestine, into the lymph system, and then into the blood system and delivered to the target tissue. But taking a step back, my first point is that if you don't change the blood levels, you have no chance in changing the tissue levels. And in order to know if you change the blood levels, an experiment at a basic level would have to measure blood carotenoid response as a primary, because otherwise you're making assumptions. So we achieved that. And then we're moving in, as you rightly say, well, let's look at the tissue. Here we can see the tissue. See a couple of things here. We see that everyone is responding, but also, Chris, and something I really want to highlight here, and I've said this in all my lectures when I'm doing my COPE lectures in America, and it's in the paper. Changing macular pigment is a commitment to good nutrition, a good supplement. It takes time. It's not a silver bullet that happens overnight. It's a whole change to how the person behaves in terms of their nutrition, their lifestyle, and the use of the supplement. And this validates our earlier work more, where we see that the longer you supplement, Chris, the better the outcome. And even though...
And your graph goes, your time span is how long?
12 months. So can you see here 0 to 12 months? And what we know, actually, if I extended time, which I did in another experiment, this continues to go up. We hit saturation. Let's go back to blood. We hit saturation in blood. I know it's at 10 days. We call that the half-life. And blood will fluctuate because diet has a greater effect on blood, day-to-day changes in diet and carotenoids. But what we see here is that the sustained effect of supplementation has a sustained improvement effect in macular pigment. So in other words, in the context of a research question that we're trying to optimize vision or visual function, really, and when I'm designing experiments now, I say at a minimum you want 10 months, 12 months if you expect to have an improvement in visual functions. And sometimes other scientists, other researchers try and do a quick study where they're doing supplementation over a couple of months and they expect to see things. And the answer is they're highly likely not to, because in order to change this macular pigment, which is the goal of the intervention, we have to do a lot in terms of having a quality supplement with the 3 carotenoids. We have to, in the first instance, fill up the reservoir of carotenoids, which is all the fat in our body, okay? And ultimately, when we saturate our reservoirs, we will have sufficient amounts available for the biological turnover into the macular tissue. And that is why, and we're not dealing with a situation, Chris, that any of the patients pre-supplementation will have sufficient amount of macular pigment. And that is why I believe this type of supplementation has been so effective, because everyone can get some benefit from it if they get access to the right supplement and if they do it the right way. Does that make sense?
Yeah.
Okay.
Yeah.
So in the second instance then, to show you that the primary outcome measure as published was contrast sensitivity. And here you can see your points along your spatial frequency contrast sensitivity curve. And we have a new paper coming out actually this year. I won't show it today because we won't have time, but remarkably, we did demonstrate that the primary outcome measure here was achieved. And in a study like this, and I remember Paul Bernstein, kind of complimenting this at one of our Bonn events to say that to put a primary outcome measure into a study like this and to achieve it is quite a unique thing. It's quite a unique achievement, if you like. But also the interpretation of this, Chris, and this is crucially important. It's kind of sciencey, but I'd love if your listeners and your viewers could kind of understand this. The whole point of doing a placebo-controlled trial is that you're comparing the results of your active group, which for those of you that can see the screen will see it's the orange here over 12 months, to the placebo group. So you're not just looking at the active group in isolation. The statistical models that we build, we call it, in this case, repeated measures analysis. And we say in that analysis is there a change in macular pigment over time? That's the first question. And as you can see visually here, that's absolutely the case for the active group. But built into that model, that statistical model is that change over time significantly different to what happened to placebo over the same time?
Right.
And that's everything you need to work towards if you are claiming a double-blind placebo-controlled trial. You have to look at your data for the active group in connection with and relate it to the placebo group and vice versa. Looking at them in isolation is not, it means that you haven't done a placebo-controlled trial. You may not have not measured the placebo in the first instance. And I really want to emphasize that point.
Yeah. So what you're saying is I could do a study that would only look at supplementation and increasing serum concentration and even increasing carotenoid. But then if I didn't compare it at the same time to the placebo in that same trial, I maybe went outside and said, yeah, another study looked at placebo. Then it's not really, you're saying it's not a randomized control trial. You're comparing a different study to a different study.
Exactly right. And you're looking at one variable in isolation. I mean, the macular pigment example here is probably not the best example because our methodology, it's kind of like an exact measurement, the variance in how we image the macular pigment. We've optimized that to a very, very high standard. But what if we have learning effects, or what if we have variability in our measurements? And this typically can happen, as you will know, when you're looking at visual functions. There's more variation in the different types of tests that are out there. And the question is what you're seeing in terms of improvement or increasing a particular target tissue, in this case macular pigment, due to variation or learning effects or placebo effects, or is it actually due to the intervention? And the only way to do that is to put the active group in the same statistical equation as the placebo group. And when you run a proper randomized placebo-controlled trial, one other thing, Chris, I want to point out is that you're comparing like with like throughout the experiment. So the patients in CREST, for example, had identical, comparable, if you like, age, body fat, starting macular pigment. You know what I mean? So we were comparing like with like. If you have intervention groups that are fundamentally different, maybe one group full of males and the other group full of females, or one group with people with a high starting macular pigment versus low, how can you interpret anything from that type of data set? Because you do not now, in the true sense, have a placebo-controlled sample to work with. Does that make sense also?
Yeah, total sense. So then,
Right.
then tell me a little bit about where, if you were going to not use, well, you don't have to specifically talk about studies or a specific study, but if you were talking about a null hypothesis and why that's so important, and if you don't have it, where you'll fall short, can you talk about that a little bit?
Yeah, well, I actually do have a study. I have an example here. I think that speaks to a lot of the issues that I was addressing. Here we can see a recently published paper, and it was in a peer-reviewed journal, in a journal called Nutrients, and this was by Pink and Davey. And if we look at this, their research hypothesis was I had a keen interest in this because it was macular pigment also. And the aim of this experiment was to evaluate changes in night vision function in individuals that took carotenoid supplement over a 6-month period compared to placebo. And if you look at the title of this, it's claimed as a randomized placebo-controlled trial. Okay, so it's going for...
The study is night vision and carotenoid, a randomized placebo-controlled trial on effects of carotenoid supplementation on night vision in older adults. So I'm going to pause there. If you're saying that right now this example isn't a randomized placebo-controlled trial, how do the reviewers at Nutrients allow this to come through? What happens? Because from a lay clinician, right? Like, my thought is, if I see something published in a journal, I can rely on the reviewers on that journal to weed out. Because what I'm thinking you're going to say is this wasn't randomized control, right? I'm expecting, right? I'm a clinician. I have a reasonably good system to evaluate studies, but I'm not. That's not my wheelhouse, right? And so how do I? So I have to put some trust in a paper or in a journal to do some of the work for me to know that this is something I can trust. Well, how can I even know if this isn't the case? How do I know what happens in these journals that we don't pick on them, but what happens that this gets through if that's not actually the case?
Yeah, so this represents a new challenge in peer review. The classic peer review is a situation that these journals have high, as I said at the beginning, have a high impact factor, that they will do a very detailed assessment of the data. Experts, I will review several papers a month in our area, and I do so with a lot of interest and care, because it's fundamentally important to do that. The first issue that we see here, and it's quite remarkable, that this paper was submitted on the 9th of August 2021 and published on the 14th of September. It was accepted on the 10th of September. Now, having been a reviewer and as an editor in many journals, I find this quite astonishing, that a peer review. So think of what's happened here. In theory, this paper has come to the journal. It has been sent out to hopefully 3 or 4 reviewers that are typically and should be given, maybe because reviewers work for free. I know I'm one of them, and I didn't review this paper. But they typically be given 6 to 8 weeks to review the paper. Then what should happen is the academic editor will look at that and see if there's value in this. Maybe there's a couple of possible outcomes. In theory, the authors will have to make minor changes and it can get published, or major changes, which can take, in some, I've been part of my own work where we spent a year with paper trying to optimize it, dealing with the very strict questions presented by reviewers and making the changes and getting it published. Okay. And that's okay. That's part of the valued peer reviewed system. So the first situation here is that this clearly didn't happen because it was published as part of what they call a special issue in relatively short period of time, 1 month. So that was a red flag.
Would there be any situation where that wouldn't be a red flag? Like, you got to get the information out quickly because it's so critical during, like, let's say the pandemic, right? We're going to get this out, and then we're okay if we're publishing it and we can retract it later. Are there situations where that would be acceptable?
I mean, if it was an excellent paper and if the reviewers of the journal were appropriately skilled to look at the work, and if it was a quick review, basically, of course that could happen. It's very unlikely though that it happens like that. The other issue is, so to tell you what's happening, I had communicated then back to the journal that I have an interest in this area. I had lots of questions. I felt essentially that a lot of the outcomes and I'll take you on a whistle tour of some of them. A lot of the outcomes from this experiment were not actually shown by the data. So the conclusions were not correct based on what the data in the experiment had presented. And I communicated with the journal. I communicated with the academic editor. The academic editor said to me that she also had major problems with this particular paper. And I queried as to how it could get published in the current form that it was published in. And right now we're at a situation that, and you may be familiar with what you can do. It's called a letter to the editor or a comment to the journal, which again is perfect in the context of science. When the journal receives a comment, scientists may want to comment on something that's positive or something that needs extra work or that they disagree with. And the authors of this paper have the right, of course, then to explain it, or to maybe agree that it was a mistake or it should be changed and so on. So we're still in the middle of that. I'll tell you what's interesting is that it's taken significantly longer to have the letter to the editor published than it did to have the entire full paper published.
That's interesting.
Isn't that interesting? So what I can tell you with openness and transparency is that myself and my co-authors here from the NRCI have a letter to Nutrients. They've told us that they're waiting on the reply from the authors, and they intend on publishing both our letter and the reply to that letter when it's available.
So
we'll wait.
So John, then let me ask you, when that becomes available, you want to have a conversation with me and with them on this podcast?
I would love it. In fact, again, I'm glad you asked, because how I came across this paper is that I basically saw it on LinkedIn, and it was being heavily promoted by the president of the Ocular, I think it's the Ocular Nutrition Wellness Group. Is that correct?
I believe that's
in America.
Yeah, or maybe it's the Ocular Nutrition Society. Is that right?
Maybe it's the Ocular Nutrition Society. Sorry, I'm not overly familiar, but I do. I basically commented on once I saw it published that I had some issues with the data. Unfortunately, my post was removed.
Who would do that?
Because I saw the president of
so they can remove that. They can remove that in the settings.
Well, they removed it from the LinkedIn. Okay. I think that was the decision. And I queried as to why they removed it, because all I asked for was an open discussion where we could have a very professional conversation as to, and I'll tell you why this is really important. Because I've been the one with other colleagues that we've been trying to give confidence to optometrists that nutrition has a major role to play. And when some of the claims that are made within this are clearly not valid, this creates a major problem, and it brings a whole layer of uncertainty to the validity. And I also have a problem because, we spent nearly a decade preparing, conducting, interpreting, publishing CREST. And then when you see something that's like this, that is making these claims, which clearly is not supported by the data. And I'll show you now in a second, essentially the null hypothesis stood up here. Their test hypothesis wasn't shown by their own experiment. And what a scientist should do in that situation is accept that and try and understand why that happened. Because that's where the big learnings come from, actually. It's not always just having that your test hypothesis is correct. It's what did the experiment show us? In this case, it was a high zeaxanthin intervention. There was no meso. Could it be that if meso was there, the results would have been better? Could it have been that if the intervention was longer than 6 months, that the results would have been better?
And so but it wasn't randomized. How do you where do you see that in the data?
Let me show you. Yeah, I have a couple of slides. So we've gone through the aim. The first data that you see in this paper. Now you look at this, Chris. Okay, I won't. So I'll tell you one thing. The red line represents the intervention, and the black line represents the placebo. And this is a measurement of macular pigment, and we're looking at 6 months of intervention here. Now, remember what the research question is, that you're going to give this intervention and it's going to significantly improve your macular pigment in a way that's different to the placebo.
Okay.
Do you think that data suggests that that's the case?
Yeah. So for the people that are listening, you're seeing essentially parallel intervention and placebo lines, and the intervention line actually is lower for MPOD levels than the placebo line, but they're parallel along the whole way. So just to answer your question, John, I would be no.
Okay, thank you. And I'm not trying to be funny here. I'm just saying I'm so confident in this. I'm putting it there for you to even look at it, and you've summarized it absolutely perfect. The other problem here, Chris, in terms of the macular pigment is, the statistical analysis that was conducted to report what went on here did not look at the active group compared to placebo. It basically ignored, not always, but it ignored the placebo in the most part. And it just looked at changes in terms of what was going on in the active group. If we look here, and that's why we say it failed to conduct any between group analysis. So by analysing only the experimental group effects, they cannot be justifiably attributed to the intervention if any effects were happening thereafter. And the other thing you may observe here is that the starting point of the intervention group, of the active intervention group, is significantly lower. Not just at the beginning, right, but at the end of the experiment. Can you see that?
Right.
So there's no crossing, there's no real improvement, there's no significant change. So if the whole idea here was that we had to achieve a change in macular pigment to change vision, I think this experiment clearly shows that this intervention used didn't achieve that. There's a couple of reasons for that in my view. One is the duration. One is the fact that it doesn't have the 3 carotenoids, mesozeaxanthin and so on. I've been very clear on my communication about that over the years before this study. If anything, I'm kind of glad that this happened because it's validated a lot of what we've been saying.
So is it? Are you saying? I'd have to go back. The claim was that this actually does improve vision. That supplement does improve vision.
Yeah.
But the
claim was that it improved macular pigment,
right,
and it had positive effects on night vision. Yeah. So how can that be the case when it's not improving macular pigment in the first instance? The whole hypothesis falls at the first hurdle,
right? Because
the intervention didn't change the target tissue of macular pigment. Now they claim in the paper it does, but the data really shows that it doesn't. And I've requested the data from the authors. Which is something you can do as a scientist. You should have the right to accept data anonymized where you can redo analysis if you like.
Mm-hmm.
I would make the CREST data available for anyone that wants to look and try and repeat our analysis. No problem. That's another layer of quality that an experiment should have. So I've pointed out some of these already. The baseline macular pigment values between the active and placebo group are not comparable. And at 6 months, and I think you pointed this out yourself, Chris, the intervention group remained lower than the placebo. So the difference in baseline values. And the other thing is, even if they did do the proper analysis, given the significant and stark differences of the pigment at baseline, they would have had to control for that throughout the analysis. And that also wasn't done in the statistical models that were used here. And just some other relatively small points that we can see. Well, they're crucially important, actually. The right eye, the claim here is that the right eye supplement group showed an increase in macular pigment going from 0.35 to 0.41 over the 6-month intervention. But the device used, so they used the quantify system, used to measure, exhibits a higher retest variability than the type of change, the variability that we see.
Well, you brought up devices before, and so what? So obviously there's a different device that you believe is important, or the device really makes a difference in how you're monitoring these.
Yeah, we talk about quality, state of the art in terms of assessment. This is a subjective system that doesn't use a peripheral measure in the most part. They tend to not do that. It's highly variable. Their own data shows it's highly variable. The retest variability is as high as 0.18 optical density units, whereas the changes that of the variation that we see in both active and placebo are lower than that in terms of at the different time points. So you can't claim anything beyond basic variation of the method, is what I'm trying to say here. And I'm not surprised. I'm very familiar with, I've been saying for a long time that these systems are subjective, they're very variable, and this data now, and that of previous reports show that to be the case. So the reported improvements by the authors here essentially are well within the method variability. And like one other piece to the data, actually, if we look, because I've studied all of it, out of interest, if you look at the data on the figure, Chris, so
this doesn't match the data in the text.
Doesn't match the data in the table.
Yeah.
So you can see here, what does this value look like to you? So this is the B is the left eye. Okay, so we're looking at the left eye and we're looking at 6 months, and you can see up here, whereas the left eye's mean changed from 0.35 to 0.37, and that's clearly not 0.37. So these are, when I constructed with my colleagues the letter to the editor, we essentially, and it's a significant length of letter because there's so many issues with this paper, we clearly just point out in a very scientific way all of the concerns we have about this. Just very quickly, I won't go into it in too much detail, but here's some of the vision outcomes, Chris, which goes back to the reason why they did the experiment. And what do you see here? So we're looking at, in this case, we're looking at reported effects of the active supplement for active versus placebo. And this one is a photostress clear. So again, we're looking at a red line and a black line. Do you see any differences there?
Yeah, no.
Yeah. You know, honestly. And so it's just bizarre that the data that was presented clearly showed that not only did the macular pigment not change in a significant way, or clearly that it wasn't different to placebo, that when we looked at the outcome measures of vision, there's clearly some practice effects which are happening, but they're identical for placebo. Now, what the authors did here was that they looked at maybe the change of the baseline to 6 months and said, oh, vision got better. But they did that outside of the context of taking into consideration what happens as practice effects. And the only way to know that is, as I said at the beginning, is to use your placebo data. They didn't.
Who paid for this study? Do you know? Did they disclose that in the paper?
Oh, yeah, it's in the paper.
Yeah. Okay.
Yeah. Okay.
So here's what I think, because I want to be respectful of your time, and I think this is helpful to think through what a study is telling us. And I'll tell you that, you know, most people, when I think about it, they'll read a headline. The headline will of the article. They'll read the article title, and they'll say, "Oh, that's interesting." Then they'll read the abstract, and they'll get through the abstract. They'll accept most of the conclusions as being accurate. But I find the same thing. I'll read through a study because I'm thinking same thing. It's like, oh, it's interesting. I wonder, that kind of flies in the face of this other thing that I'm thinking about. I want to look at the rest of the paper. And hopefully they align. Professor Nolan, as always, this was another great conversation. I can't wait to have it again in a few months. Hopefully it'll be sooner rather than later. But thanks so much for being on. It was a lot of fun for me. I think this is going to stimulate a lot of conversations, and hopefully it'll bring to the surface some of the things that you hope will be brought to the surface as well. I think the entire community always benefits from a vibrant conversation and discussion between people who disagree, because we can find ways to advance and take better care of patients. So thanks so much for doing this.
God bless you. Lovely to see you again, Chris, and keep up the great work you're doing.